Welcome. My name is Ryan Belikov. I will be your instructor for this course on ergonomics and IH. So everybody should be a graduate student, whether you're an online student or in person. Uh, so this course shouldn't matter that much. So a brief introduction, most of you have had me, but there's several that have not. So um, just a little bit about me. So as you see, it says DC PhD. So I am also a licensed chiropractor. So I've been a licensed chiropractor for 19 years. My PhD is industrial hygiene. So ergonomics is so dear to my heart. When I've done most of my research has been in ergonomics, but I do have some aerosol research as well as a wide variety of safety uh, sectors that I have done. But this course really is where my expertise lies, and I hope that I can instill my passion into you guys on this topic because it's very important. Even though the OSHA regulations is under the general clause, which this topic is going to be repeated throughout the course, so very important. Usually, almost all the sectors that we have in the U.S. The top three are ergonomics related. And so even though there's not strict guidelines, it's huge no matter what workplace you're going to have to initiate some prevention strategies and design of ergonomics in the workplace. So this course for people online, it's a lot shorter. So we're looking at 8 to 9 weeks. For those people in person, we're looking at 16 weeks. So quite a bit of difference, but same credit value of 3 credits. So we'll have it throughout the weeks and still a similar structure. Of course, the summer online people, it will be a lot more condensed. So to go over the syllabus a little bit, our book that we're going to be using is Intro to Human Factors in Ergonomics. So we have the 4th edition. So you do not have to buy that. It's on campus. So all those materials as an ebook is available to you. So there's no reason to buy it. And as well as these presentations are going to be there. I have taught this course several times, and one thing we're trying to initiate is more of an interactive for those people online. So have patience with me on regarding that, but we'll move forward. As far as the ABET accreditation, there's not that much here. So we got conduct qualitative and quantitative hazard exposure assessments. So this is what I find that students really like about this course is we're doing assessments most of the course. And so you'll have those materials. So how to evaluate the lower back, the movement of that, what worksheets we're using, and going through that step by step. And so at the end here, at each week we'll have some exercises and quizzes that you'll submit, as well as 2 tests, so a midterm and a final, pretty straightforward. And then there's a project, so you'll do an assessment of a workplace. Many of you work at a facility, so that would be an easy one. For the most part, as long as it's not office ergonomics, please do that. So my only stipulation is it's not being office ergonomics, because we'll have a separate section just on that you'll do office ergonomics assessment. So think about if you're not, at a place that you think would be a good ergonomic assessment, think about a place that you could do one at. And by all means, you can ask me questions. So on the syllabus, I'm usually pretty good about getting back to people within 24 hours. Sometimes, I might be on a trip for a conference and those types of things, so give me a little patience. But usually, I'm really good about getting back to people. I've heard of other Universities where they take a long time to get back to people, a couple of weeks. So if there's ever a wait, I would say, the policy for the university is use Canvas for communication. That's mostly to protect you. So you have that documentation in case something falls through the cracks, and then we can figure it out together. But on there, yeah, I listed my phone numbers for the office, my cell. You could use those, but again, that Canvas would be ideal. Other metrics for ABET is design a procedure to address industrial hygiene related. So that really comes down to your projects that you'll do in the workplace. And then produce a report. Again, mastering the subject of a high level communication. So that comes back to that workplace assessment that each one of you will do. So with that, that pretty much gives a pretty general overview. Um, as far as the grading score, 90% and above is an A. That A minus going to that 93% or above, and then just, the standard metric. So if you have questions on that, please let me know, and we'll get started. So course objectives. Ergonomics is very broad. So most people think of ergonomics with the movement of the body. It's definitely that, but it's so much more. So I want you to think of it more of work, and we'll go through the definitions to kind of highlight that. But through this course for ergonomics, we'll start with the history and evolution of ergonomics, how we make applications through human design, performance, capabilities, all of that plays a role in ergonomics. And then, so what is ergonomics? If we break it down in the Greek terminology, ergonomics, ergo means work, nomics means natural work, law of natural law. So we're looking at, if we go to pleasant, which if we combine those terms, the scientific study of work. So he defined that in 1991. There's definitely been others, different definitions. As you can see, this is our book here, Intro to Human Factors in Ergonomics, where they say the study of people at work and considering their capability as well as their limitations. So that's really important. So it's a lot more than just the movement of an individual, looking at all the tools we use to do work and how our body is accomplishing that. So every time we use a tool or machine, we interact with some kind of interface, whether that be a keyboard, a tool, a handle. All of those are examples of how we can use ergonomics. So this abbreviation HFE, that stands for Human Factors Ergonomics. So that definition is how best we can design tools and machines to optimize our interactions with these environments with work. So our aim with ergonomics is to maximize this capability between the system with the main focus on the user. So in ergonomics, we need to look at capability in a number of different levels. So we have biological, anatomical, physiological, behavior, and cognitive. So each one of those have different nuances. So just spatially, where we put the knobs on our stove can matter. So, we try to have a universal, this is the height that the knobs should be to fit the greatest population, right? And then we can have different things like the movement capability. When you turn the steering wheel for a car going right, you expect the car to go right. And then we can have conceptual capacity. So, for example, there's certain things like skull and bones or red means stop or emergency, right? Those mental already taps into our pre-existing mental models to correctly react. And then we have, the physical demands versus the biological. So for high force, if we were lifting something off a shelf, we could use instead a vacuum robot arm to eliminate the amount of forces that need to happen. For awkward postures, we'll get into it. Overhead is usually not good, so using some kind of arm so we can keep it close to our body. As far as repetition, our bodies are not robots, so they break down just like a robot does, but they're better at repetition, right? So trying to use maybe a job rotation to reduce the number of repetitions a worker has to perform for that work, such as automotive. They often do job rotation and change it up. And then the cognitive, we don't usually think of cognitive with ergonomics, but it's definitely part of it. And so recently at Ohio for their Air Force, so, we were looking at ergonomic demands. Oftentimes, there's a lot of talk about drones. They're looking at 17 different screens, how to operate those drones. So there's a cognitive load, right, with us using that machine. And so trying to figure out how we could best use that so it's not as fatiguing, but operates at optimum scale. And then we have modern databases for human factors ergonomics that contain so much information about capabilities. The military is probably one of the number ones, especially with anthropometrics, which we'll get into. So let's look at the evolution of work. So we have pretty much five main time periods. So hunter and gatherers, so where we hunted, animals for our main food source. For the greater majority of, humankind civilization, we got agrarian society. So this is everything before the 1800 to, 10,000 years ago. And so that is where we use agriculture as our main food source. So that's really what increased the population. We got better at cultivating food. One of the big inventions was a plow. So this was, over 500 years ago. And it caused a population boom, right? And so thinking about how that we transitioned into the industrial revolution, so where we use machines to not only produce our food but different items like clothing and all of that. So that transition, especially in the beginning, was hard because we did not design these machines to be human friendly. We'll kind of go through that, and more recently is that informational society. So using the internet, how it boomed with computers, and so now they say we're at the age of conception. So I think this is so true with that with AI on the scene now. Even though AI is definitely a tool, you'll see a lot of transitions of work where we look at the creativity of the mind and how we incorporate that into work. So this is one of the new bestsellers, The Whole New Mind, that talks about this age of concepts and how we're changing work. So some history on ergonomics. So we're going to start with Leonardo da Vinci. This was European Renaissance. During that time, he's definitely known most famously as a painter, right? We got Mona Lisa, Last Supper was his big ones, probably the most famous paintings in the world. But he was also a scientist, a writer, all kinds of stuff. This was, by all rights, a genius. And he, this top one here, he did lots of designs of anatomical, but also really advanced machines like flying machines and those type of things. So, I think he is a good start. And then we got the father of occupational health, Bernardo, and he's also the father of ergonomics. So his last name, Ranciski, if I can say it right, just say it fast. So he was a physician looking at how work injuries happen with this ergonomics as a physician. So really important work. The last person on the list is a Polish guy. He's on the bottom left here. And even though he's most famous for the sundial, interesting, he is also a scientist that first named the term ergonomics. So that's why he's on this list for the history of ergonomics. So all three very influential in this field. So, in the history of ergonomics and human factors, positioning psychology as number one and ergonomics as number two really highlights the shift on how complex systems are designed. It represents a move away from forcing humans to adapt to technology towards forcing technology to adapt to human nature. Historically, psychology takes a lead because it is the why and it rules the human's capabilities while engineering provides the how to build the actual physical solutions to the rules. So historically, as it unfolds, World War II was a huge movement in this more of the physical engineering because we were developing airplanes, right? So in World War II, the war broke out, and there was B-17 bombers, and that even though the training was really rigorous, the crash rate was extremely high because they were not made for humans. So the engineers had to step up and apply these machines, even though they had spent millions and millions of dollars on, how to win this war. They didn't consider the human aspect of it, and that's why it was a really dangerous during World War II to be in one of these bombers, just because of the crash rate. And then, as time progresses, for discovering technology, human error is actually, bad design. When we look at these cockpits, they realize the crashes weren't, due to the pilot's error, but caused by just basic human design and psychology. So the engineers had to place levers for landing gear and the wing flaps next to each other. These were not, ideal. So under extreme stress and fatigue, the brain wouldn't recognize. So they have to separate these controls out to make it safer for humans. So psychology, even though, we're talking about design, it's really plays a fundamental role on how we use these machines, right? Um, and so, this unfortunately persists even now, and such as the psychology establish the limits of us as far as our memory capability, our physical capacity, our spatial recognition, And so we need to fix this by recognizing human biology and cognitive architecture do not really change. So, to summarize, so engineering creates a physical world, but the psychology provides a blueprint of the human mind that the physical world must accommodate. So without the psychology as number one, and engineering's number two simply builds upon that system that our humans are hardwired um, to fail at using. So there's no question ergonomics has been influenced by a variety of fields. And, the three main disciplines is, that industrial engineering that we've already talked about, but it still plays a role now, industrial design and systems theory. So, I've had the opportunity to go to a lot of car manufacturers. And so, for example, when we went to the Ford one, the whole frame sits on this big blow up balloon and it will change the height based on that worker that they already designed for a program. So that's pretty cool. Whereas Honda had it more overhead and they had an arm that would, change a little bit based on the height. All of those are, influences at how we're building these machines, such as a car, and ergonomics plays a role. So some modern pioneers in ergonomics. So this is late 1800s. Prior to, we talked about like Leonardo in the 1400s. So the first person here is Frederick Taylor. This is known as also Taylorism. He coined the term scientific management. So he didn't think that employees should be entrusted. They needed strict management and developed a scientific process on how things should be made. The next group, very similar time, Frank and Lillian Gilbreth, they are known in the motion studies. And so they coined some terms and they looked at 18 different ways to for his movement on this motion pictures, such as search, find, select, grasp, position, use, disassemble, inspect, transport, rest, all of these in plan. So different motions they looked at, and they were actually doing video. So this was during a time where, not only the product mattered, but how it was being made. They saw that there was efficiency and they could increase their profit values by looking at this. Lastly, the Hawthorne effect we'll talk about. And so this is a famous research study done in 1920s at the Hawthorne Electric Company. And so basically they looked at these factory workers in this electric plant and first increase the amount of lighting. So would you expect it to increase their work productivity? I would think probably better lighting, creates a better atmosphere, and that's what they saw. But interestingly, then they decreased the lighting, and they still saw an increase. So what Hawthorne effect theorizes is just being observed can increase the productivity or change the behavior of the subjects. And so, as you can imagine, in the research realm, this kind of phenomenon became really important. Even lighting is part of work, and so studying how people work. So these are big ergonomic pioneers. So we already talked about these B-17 bombers in World War II, but I wanted to show you some pictures. So notice here that landing gear is right next to the wing flaps in this very confined space, right? And so just as an example of how, we initiated, we needed to use good ergonomic principles to make these more efficient machines. So a more newer approach is this psychotechnical systems of area that takes a holistic approach to design of engineering projects that involve both the interaction of the social and technical elements. So a simple example is a designing of a website. So we have a back end and a front end. Let's say Bob is responsible for the back end, the coding and infrastructure of that website, whereas Sally, let's say, is example for that front end, the graphical interface of the two. So simplistically it works, but until that company evolves into like an Amazon where you have hundreds of people on both aspects, then the system gets much more complex. An easier example would be like transportation, for example, for a city that has subways and buses. So they're designing in a confined space of where that residential area is versus the industrial and like the commercial areas and how it interacts with each other, right? And so this is in 1951 they coined this term social technical systems theory, looking at both the social and psychology consequences of this interaction. So they were more particular looking at coal miners during this time, where miners were having mental health disorders due to these conditions that they were living in. So, human performance psychology, this still had its roots in practical problems, how to reduce the time taken to train a worker to carry out a task. So, again, that really comes from that industrial revolution time, right? And so there's traditional methods that now we have more, um, you know, technology approaches that investigate this feedback where we are looking at behaviorism, so response, stimulator response, and how to reinforce that stimuli with the environment, right? So let's give examples. So let's say you're about to run a 100-meter dash and someone comes up to you and says, I really want you to win. Here's $100 if you win. And so, usually that person performs better. And that's all because of this human performance psychology. And so when I think about this term, I relate it to really four things, that motivation, the focus, the confidence, number one, and then reducing anxiety. So even though this is different, than mental health well-being. I would think of mental health as the overall well-being of a person. They are interrelated. They influence each other, right? So notice in the 1960s to the 1980s, work is changing. So we call this more of humanizing the work. So increasing levels of higher education, for example. So this has definitely increased. So in the 1980s, about 25% graduated with a bachelor's degree. Currently, 2026, we have about 53% graduating with a 4-year degree, and much less in the 1960s. We're talking less than 20%. So there's definitely, been a huge increase in higher education. And then we develop programs to higher quality jobs, change that workplace design. One of these programs was British Quality of Workplace Life. And so think about how we're looking at quality of work. We're not just getting a paycheck, staying with the same job. People are changing jobs and looking at that better quality, right? So these two terms will definitely be on the test. So we have fitting the person to the job versus fitting the job to the person. So if we evaluate that, we want the first one, fitting the person to the job. So these acronyms, FPJ, you'll be expected to know that. That will be on the test. This term is so crucial. So in everyday life, I think about my first car, 1981 Honda Civic. It was tiny. I'm a large person. I'm, close to 6'2", and that car was not designed for me. In the workplace, oftentimes they're not designed for people. Costs, different economic concerns influence why that workplace was designed that way, usually not considering the people involved. So that's where we come into play, right? So we want to avoid those awkward postures. If they have awkward postures, we want to change it up. But if we have a tool, we want to work smarter. So fitting that job to the person is an underlying assumption we want, and that's good ergonomics. System design is a large scale process, so we need to formulate our system goals, our analysis of the functions, the design concepts, the realization, the validation, and how we'll reevaluate if we're doing the work that we want to. So let's take example of the cloud. We have our OneDrive, right, that we use, and with that OneDrive, there is a complex, large system. We have a number of servers, dozens of servers that are operating, but we need a process that double checks to be able to maintain it as well, change those servers out. How if we turn one offline, there's a backup system. All of those are part of that system design process. So no matter what the system is, we have trade-offs, right? This complex system, but optimally, and this is definitely going to be on the test for ergonomics, we're trying to look at four things to optimize productivity, efficiency, quality, and safety and health. So that covering my head is health. And so very important concepts. So the last concept there, system evaluation. So our key indicators. So new technology takes time to mature, constraints on IT productivity. These productivity gains were consumed by additional costs while maintaining and replacing that technology, which usually rapidly become obsolete, right? Underinvestment or misplaced investment, so a growth in that activity can increase that capacity. Again, other things to include for that systems evaluation is non-productive, so waiting for the programs to run or help to arrive, redrafting, computer games can be part of it. It's definitely a new approach. The internet, despite its popularity, the internet consumes time because it is a large responsive time. So, we often look at how much time we spend scrolling, right? And how much time is wasted with that. Overemphasis on the quality of the proportion of the value being produced. And lastly, with employees coping with ever more complex programs. So ideally, software should be user friendly. And often with times we just say, oh, I'm just not smart enough to, figure this out, but that's just bad programmer, right? A good program should be intuitive to that user. So again, this is our handbook for human factors, the fourth edition. It will be available on Canvas for sections for you to look at, so you don't need to buy it. Again, with human factors and ergonomics, three broad domains of the physical ergonomics, which we typically think of, the cognitive ergonomics, and the organizational. So if we look at that first one, the cognitive ergonomics, so this could be perception, memory, reasoning, and motor response. So for example, phone numbers, often 10 digits because it's easy for us to put in our short-term memory to be able to memorize and repeat. So a lot of research has shown that if we go beyond that, it's very difficult for us to put in our short-term memory recall. So this cognitive ergonomics, professionals are connected with mental loads that process, including perception, memory, and reasoning. And lastly, that motor response of decision making, as well as skilled performance. So this can even be musical, right? Human reliability, error diagnostic, modeling, and training. And so lots of research has been done with this. Human factors, I think one of the experts in human factors in the US with cognitive ergonomics is University of Florida. So they are doing some great work with this area. So other things to aim for good cognitive ergonomics is to design to support the mental process based on perception, memory, and attention, workload. Such awareness can make a good decision making and solve problems. So one of the organizations for international is the International Ergonomics Association. So they have a conference. So there's a biannual, they call it, where they combine the human factors ergonomics in the US with the international one. And so a good one to go see. Usually they do it every 2 years for this international concept association. They're looking at the technology of tools to assess humans with this ergonomics. So cognitive ergonomics is concerned with also the understanding of the behavior of the human as we interact with machines. This information is used to design the machine interfaces and controls. So think of this big complex, machineries that we had in the 60s, which has drastically decreased. One of the reasons why like the iPhone was really important with the touchscreen. That interface simplified it. Steve Jobs always thought of how can we reduce it, how can we make it very simplistic. And the iPhone does tons of complex things, but trying to make it more user-friendly. And as part of that, system, we have employee participation. So employees have to acknowledge the need for that participations. They have to trust their participation will not have negative effects. So they, interact. So think of, this classroom. If I asked one of you a question, probably no one would raise their hand unless they felt that they could trust people without having a negative consequences, right? Employees have the perception that changes that are being introduced in a legitimate way. So think of oftentimes safety committee. People are more engaged if they feel that their voice will be heard. And implement correctly. So this is why it's important to have a safety committee that has workers that actually perform the work, part of developing those protocols rather than just management. And then employees have to be given a real role to play in the interjection of testing of new ways of work. So just expanding it, let them have ability to climb up the ladder, right? So other things with cognitive ergonomics. So this was in 2011, so a little bit more recent, looking at the mental process, such as the perception, memory, and motor. So all of that is the same, but with regard to the interaction of the human and the other elements in that system. So we have to look at the mental load, the decision making, the skill performance, reliability, stress, and then training. So this is a good interface where less software, we're usually using computers on that cognitive interface. So, it goes back and forth. We're using a keyboard and mouse to input, but also the screen is giving us an output. So that's kind of an interaction between the systems. So that handbook, of human factors, even though what you have is the third edition, the fourth edition still, is 2012. With the age of information, massive data revealed that cognitive limitations of humans, how much we can handle. Uh, Again, a lot on cognitive, but we don't think of work as much as cognitive, but it's our brains, our ability to interact with that environment. And so this is an example of a EEG. And so, you know, this year we're looking at a study about cortisol and stress. And so cortisol is one of the main stress hormones in the body, usually elevates in our body when we're stressed, but it goes up and down throughout the day. And so different ways to measure cortisol. We can do blood measurements. The one we're doing in the most recent study is using the saliva. So the person that gives a small sample of their saliva, we send it to the lab. It gives good levels of cortisol during different tasks. And so this is a scan showing different levels of the brain that, highlighted. We definitely have a cross hemisphere during different tasks, right? And different parts of the brain that are responsible, but it's all connected. For as execution, down here is our map, kind of, clockwise, usually in the middle. We have that motor, how we're actually moving the body, but then we have the orientation, how we're doing different tasks, how it's all connected. So hopefully we'll conclude this lecture. You can define what ergonomics is to remember study of work and how we're doing work, and then recall some underlying principles. Remember, we're trying to optimize productivity, quality, health and safety of that person. So really key concepts, and then describes a little bit of that history. If you remember the father of ergonomics, Berninsky. So all of those are good concepts. We'll end this lecture. Thank you.